of functions notation. So what we're going to do is we're going to plug the g function in to the f function, and if the result is x, then these are functions. So if the result is x, once we do this plugging in, plug g in to f, then these two things are functions. So if I have this function, f, which is 4x, and this function g, which is x over 4, I'm going to plug this value in for x into the f function, and I'm going to simplify it. So 4 times the new x, which is x over 4. And I'm going to simplify that. So when I simplify that, 4x over 4 is indeed equal to x. So these two functions are inverses. So I could say, I don't want to make a big deal about this, the inverse of f is equal to g. Okay, so our second example, we have g function is x plus 3 over 7. So in place of x in the f function, I'm going to write all of this. Okay. So, and again, if I simplify that and I get x, these are going to be inverses. So 3 times x plus 3 over 7, because that's my new x, minus 7. So again, this is my new x.
Why did you bracket it like that?
Just, I could have parenthesed it. I just was making it kind of bold and stick out. So I'm going to multiply the top by 3, because this is really 3 over 1. So in fractions, remember you multiply top times top and bottom times bottom. So this becomes 3x plus 9 over 7 minus 7 over 1. So again, I'm going to find a common denominator. The common denominator is 7. So 3x plus 9 over 7 minus 49 over 7, because 7 times 7 is 49. What I did was I multiplied this fraction by 7 over 7 to write an equivalent fraction to give me that. So 3x, 9 minus 49 is 40, over 7 is, how do I simplify that? Well, guess what? That's not x, is it? And I can't simplify it anymore. So since this is not equal to x, then these are not. f negative 1, or x, is not equal to g of x. And I can say that because I didn't simplify to x. Another thing that you might be asked to do is to simply write the inverse. So these are the steps that we practiced after our test. The very first thing that you're going to do is replace f of x with y. F of x is equal to x to the third plus 2. The next thing that the steps in the textbook suggested that you do is switch y and x. So this now becomes x to the third equals y. I'm sorry, not x to the third. Just x. So switch these. X equals y to the third plus 2. So you see it's exactly the same, except in place of y, I wrote x, and in place of x, I wrote y. So the last step, if you remember from our activity after the test, was to solve for y. So in this case, I'm going to move the 2 to the other side, so it'll be x minus 2 equals y cubed. Well, just like the opposite of squaring is square rooting, the opposite of cubing is cube rooting. So I'm going to take the cube root of both sides. So it's the cube root of x minus 2 is equal to y. And so this is the inverse function. And you would finish that up by saying that f inverse, this is f inverse, is equal to the cube root of x minus 2. So, in this one, again, we are going to write the inverse, and we're going to write the inverse by following the steps. We're going to first switch this to y instead of f at x equals 2x plus 1 over x minus 3. And so the next step, if you recall, was to write x in place of y and y in place of each x.
Isn't that the next way?
Yes, it really is. It just makes it a little easier rather than writing this and switching it. You could follow this through with f at x each time if you wanted. Then you would be switching x and f at x. Okay? So, the first thing you need to do in this problem is clear the fraction. I don't want a fraction because I can't simplify. So I'm going to multiply both sides of my equation by y minus 3. When I multiply both sides of my equation by y minus 3, these two pieces cancel. This cancels with this. Okay? So, on this side, I'm going to have xy minus 3x equals the top now, 2y plus 1. So you remember I'm solving for y. So what I want to do is to have everything with y on one side and everything that doesn't have y on the other. So I'm going to subtract 2y from both sides. So xy minus 3x minus 2y equals 1. So now I'm going to move this piece over because I want that one to be on the other side. It doesn't have a y. So xy minus 2y equals 3x plus 1. Okay, so we have this, and this can be factored into y times x minus 2. And again, now I have the y kind of by itself, and 3x plus 1. And then I'm going to divide both sides by x minus 2. So these cancel on this side. And so now I have y equals 3x plus 1 over x minus 2. So what I can say is that the inverse function of x equals 3x plus 1 over x minus 2. Piece. So the final step is the graphs. So let's look at the graphs. Okay, so this looks kind of scary, doesn't it? Let's see if we can take some of this. I forgot that I didn't erase things. Senioritis? Who has senioritis? Nobody in here has senioritis.
You're reporting.
So, if you have a graph that you're supposed to find the inverse of, remember, if you fold it on the line y equals x, and it matches, then it is an inverse function. Okay? So, for this one, right? For this one, is it one way to look at this when we rewrite this as an inverse function? The table, remember the y becomes the new x, and the x becomes the new y. So this is my ordered pair. Okay? -3 and 0. And -1 and 2. So I have these ordered pairs for the inverse function. So here's the original function, and the points are noted. And here is the inverse function. So -5, -2, -3, 0, and -1, 2. So those are kind of in a straight line, aren't they? So there's my inverse function. Well, how is an inverse function also a line? Well, yeah, it's the x's and y's switch. Now, if the first function wasn't a line, then the second function wouldn't be a line. But what I want to ask you is if I put in this line here, y equals x, and I folded that on the dotted green line, wouldn't the new pink line match the black line?
No. One's on it.
What?
One's on it.
Oh. But when I fold them, since this one goes on to infinity, they would match.
Yeah.
Okay. So the point that I'm trying to make is all you have to do is switch the x and the y, which was the answer to the last question after your test last week. Right? Some of you went into great detail, and that's all you had to write. Okay, so let's take a look at another graph. In this one, the table's not provided, but you still could write the table, couldn't you? So in the original one, the x and the y, might be -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And I just obtained those points from the graph itself. So now I'm ready to write the inverse function. So the inverse function is going to switch the x's and the y's, right? So 9 becomes my new x, and -3 becomes my new y. 4 becomes my new x, and -2 becomes my new y. This stays the same. This stays the same. This switches, and this switches. So as we graph this one, this is a one-to-one function, is it not? And this is what Nancy was talking about in the video that we watched earlier. The result is not a function, because you can see what happens when we graph this is that we're going to get this sort of function, right? When I graph all of these ordered pairs, I get this. And this is not a function because at 2, I have 2 different values for x. So while this is the inverse is not a function. So this relation is not a function because it looks like this and it doesn't pass the vertical line test. Do you remember what the vertical line test is? It does not pass the vertical line test. So here is 2 different outputs for x, right? So that is a picture of the inverse, but that inverse is not a function. Okay, so we can graph all sorts of ideas. So can we graph the inverse of this function? Okay, this is not a function. We could graph the inverse of it. It would be a relation. But this one is not a function. So this is not a function. Therefore, we would not be able to do the inverse of it. Okay? So this one is not a function. And how about this one? Is this one a function? Yes. is its inverse a function? Well, the inverse is going to look like this, isn't it? It's going to go right here on top of itself because this is the line y equals x, and then it's going to go down here. So is the inverse of this a function? No. Okay? So this is also not a function. Okay?